Hello, guys. Welcome to another episode of this learning process. So, in this episode, we are going to be treating non-flow processes and reversibility. So, just like we treated in the last episode, we treated the flow processes and the steady flow energy equation. So, in this particular episode, we are going to be looking at the non-flow process. So, the first we are going to treat is the constant volume process, which is also known as the isochoric process. So now, what is a constant volume process? A constant volume process, just as the name implies, is a process in which the work done is zero due to what? Same volume or unchanged volume. So how do we do this? Mathematically, you can say that mathematically we mean that V1 is equal to V2, which is what? Constant. Now, from the first law, we know that Q plus W is equal to what? U2 minus U1, and that W is equal to what? P dV minus P dV. Okay, minus P dV, because we are using plus Q plus W, so minus P dV. So dW. So finally, work done is what? P what? V1 minus V2. So which is 0 if V1 is equal to V2. Alright? Then imputing this into the first law, this will become Q plus 0 is equal to U2 minus U1. Hence Q is equal to U2 minus U1. Now, this is the heat transfer. For a vapor system. So, just like we all know, if W is equal to PV, remember that PV is also equal to mRT, where T is a specific heat capacity of a gas, perfect gas. Okay, so can we also say that Q is equal to mCV change in T? This here is the heat transfer for a perfect gas. Under what? The constant volume process. Okay, so having said this, from the ideal gas equation, P1 equal to T1, not T2, okay, equal to what? T1 equal to T1 equal to what? P2 V2 over T2. Since V1 is equal to V2, the formula becomes what? P1 over what? T1 is equal to P2 over T2. Alright, this is what we'll be working on. So, to make this more elaborate, we're gonna take some questions that will make it sink down into the brain. Okay, let's take a question. Okay, example 1. In a vessel of volume 0.3 meter cube contains a dry saturated steam at 17 bar. Calculate the mass of steam in the vessel and the enthalpy of this mass. Now, it's very simple. The first thing you should do is what? Bring out your parameters. Parameters being given to you. So firstly, you write what? Your solution. Your solution should come first. So you write solution. Okay? Solution. Now, we have what? The volume. V, big V. Okay? The big V is 0.03 meter cube. Now, remember in our last class when we discussed on the topic working fluid, we explained when a vapor is dry saturated and when is what? Just ordinarily saturated. So a dry saturated steam means that the dryness fraction is unity, and a saturated liquid means that the dryness fraction is 0. So for this dry saturated steam, we have our dryness fraction, which is 1. Okay, and our pressure given to us, P. Pressure given to us is 17 bar. Okay, we have done this. So to find the mass, remember that specific volume, small v is equal to volume per unit mass. Anything specific is over mass, both enthalpy, entropy, and the rest. They are specific when they have been divided by unit mass. Okay. Yes. So, how do we get the specific volume? Remember that specific volume is equal to xvg. Okay, xvg. That means from the steam table. So if you have your steam table, like I have mine here. So if you don't have a steam table, you can download this steam table by GFC Rogers and RYR Mayo. So that's what I'm using. That's what we are going to use to solve all our questions. So steam table by these authors. Okay, download. So it's online. Download it. It's not much. So from the steam table, okay, under 17 bar, or at 17 bar, comma, Vg is 0.1167 meter cube per kilogram. So at the saturated vapor table. That's where you see this as saturated vapor table. That's where you see this. So make sure you check and confirm this value. So the specific volume now will be xvg, but remember our dryness fraction is 1, so specific volume now will be 0.1167 meter cube per kilogram. So but specific volume is also equal to volume over mass. Volume over mass. So 0.1167 is equal to, what was the volume given? 0.03 per mass. So our mass now will be equal to, when you divide, you will have 0.03 all over 0.1167. That will give us 0.2571 kilogram. So we found the mass of steam, in the vessel. Okay, found the mass of steam in the vessel. So what is the next question? They ask the enthalpy at this mass. So the enthalpy at this mass will be, remember our formula for enthalpy, H is equal to HF plus X HFG. Okay, so still at the saturated vapor table. If you open your steam table, go to this saturated vapor table at P equals 17 bar. You will get that HF is equal to 872 kilojoule per kilogram, and also HFG is equal to 1923 kilojoule per kilogram. So having said this, we'll go straight and impute them. So plus our dryness fraction is 1 already, so we add up and have that our specific enthalpy is this. Alright, is this. So the enthalpy of this mass means H is what? mH. Okay, yes, because specific enthalpy H is equal to BH over small m. That is, this is the total enthalpy, this is the mass, so this is specific, just like the volume. Specific volume is big V over m, so anything specific is divided by m. So note this. Okay, note this. Then finally our mass will be 0.257, just like we calculated, times 2795 kilojoule per kilogram. So the enthalpy at this mass is 718.5 kilojoules. So we are done. So this is the answer. We've gotten the mass of steam in the vessel and the enthalpy at this mass. So let's take another question.
It need to lick on some ladies. Yeah, we did turn up on a daily. It's how I walk up. Yeah, soft walk.